It's time to automate our scenario. Let's go back to the Caffeinate Me project and run the feature file if you've not already done so. As we've seen, and as we can see here, Cucumber generates snippets of code that we can use as the starting point for our own automated test code. Copy these snippets now. Now let's create a class for our step definition methods to go in. Create a new class called Order Coffee Steps in the source test Java folder under the Caffeinate Me package and copy the step definitions into it. IntelliJ will complain about a number of unknown symbols. We need to add some import statements so that IntelliJ can find the Cucumber annotations and this exception class. The easiest way to do this in IntelliJ is by pressing Alt-Enter. Now let's run this feature again. This time, the test results are different. We aren't getting any undefined steps anymore. We're getting a pending step and 3 skipped ones. Cucumber has found the step definitions, but each of our step definitions throws a pending exception, which makes Cucumber stop the test and skip all the following steps. This is Cucumber's way of telling us that we still have some work to do to make the scenario pass. Let's write some application code to make this scenario work. Let's start off with the first step. Kathy is 100 meters from the coffee shop. I'll tweak the generated code a little to make it more readable. Let's say Kathy is n meters from the coffee shop, and let's say distance in meters. This funny syntax in the annotation is called a regular expression. Regular expressions are widely used in Cucumber, but in practice you only need to know a handful. This one matches a number in the step, so 100 in our example, and passes it on to the method parameter distance in meters. Now let's imagine the domain model we might need for this scenario. The scenario mentions Kathy, who orders a coffee. She's a customer of the coffee shop, so maybe we could create a customer class. We also know she needs to be a certain distance from the coffee shop. So let's get rid of the exception and create a customer class. We could write something like this: customer Kathy equals new customer, and Kathy is a certain distance from the coffee shop. So we could say just add a setter, set distance from shop. And here we'll pass in the distance in meters. Now let's create the customer class. We can use Alt-Enter in IntelliJ to go faster, to make our IDE do most of the work. We go create class, we pick the application class, so it's in source main Java, and it's going to go in the Caffeinate Me package. Now we have our brand new customer class. We're going to want to add the distance from shop. So we're just going to set this as a setter, and that means we're going to get a distance from shop field in our customer class. Now this is probably a bit too simple for a proper application, but we'll just try and keep a simple setter for now and make it more sophisticated later on when we need to. We can now run the scenario, run the feature file, and see what happens. Now we can run the feature file and see what happens. And bravo, we have a passing step. Well done. Now let's move on to the next step. In the second step definition, we want Kathy to order a large cappuccino. Large cappuccino is hard-coded into the text at the moment, but I want to make this step definition a bit more flexible so that Kathy can order other things apart from large cappuccinos. I'm going to replace large cappuccino with a regular expression, a really simple one, dot star. They go in parentheses, just like this. Now, everything that comes after Kathy's orders will be passed to the method. And we need to add a parameter to accept this value. So let's call it order. So now we can say Kathy orders something, and that something will be passed into the method. Now let's make Kathy place the order. we could say Kathy place order for order. So Kathy places order for order. But to access Kathy from this method, we need to store her in an instant variable, like this. Now let's add the places order for method to the customer. We're not going to worry about the implementation just yet, because what we're really trying to do here is discover what the customer API should look like. And if we run the feature file now, we should have 2 passing steps. In the next step, we want to make sure that Barry actually receives the order. Now, Barry's not a customer, so we need a new concept. In fact, Barry is a barista. So let's create a class called barista. And we need to check that Barry has actually received Kathy's order and that the order appears in the list of pending orders, the orders which he needs to complete. If you've not come across this assert that notation before, we're using a library called Humcrest, which helps you write more readable assertions, just like this one. We're saying assert that Barry's pending orders has an item, so it contains in this list Kathy's order. But we need to store Kathy's order somewhere between steps. So let's add an instance variable called Kathy's order. And when Kathy places her order, we need to store her order in this variable. Finally, we need to make IntelliJ happy and fix the inserts. So let's add some imports from the Humcrest libraries. So Humcrest uses static imports quite a lot, and IntelliJ figures out where these libraries have to come from. So you'll be getting them from the Humcrest library. And we mustn't forget, we need to create a barista class. And the barista class has a get pending orders. Pending orders will return a list of strings. So you notice how we're discovering the API of the barista class, just like we did for the customer class as we go. Now let's run the test. Now we're expecting it to fail because that will show that our test is doing its job, that it is actually checking the right thing. You should always see a test fail before you try to implement the code that makes it pass. And here we can see the assertion has failed. It was expecting a collection containing large cappuccino, but it got null. So how could we get this step to pass in the simplest possible way? So what is the easiest and quickest way to get this test to pass? Well, in test-driven development and behavior-driven development, sometimes to get a test to pass quickly, we use a minimal or even hard-coded solution. And that way, we can explore why this solution is insufficient and what other tests we need to make the solution more robust. And it's a great way to get a really comprehensive, solid test suite and to get a better quality API. Let's do that here. Our pending orders method returns null at the moment. But what if we were simply to create a new array and return the hard-coded value we're expecting? We could say something like this. We have a list of strings, and we're going to add a value. What we're going to add is large cappuccino. And we're going to initialize this list. It's going to be an array list. And now we have this step that's passing. Let's see if we can do the same thing for Barry should know that the coffee is urgent. When we go to this step, we can have a look at the step definition and we see that we could simply do something like this, something very similar to the previous example. We can simply say assert that Barry get urgent orders as item Kathy's order. And this means we're going to have to do the same thing as we did previously for Kathy. We're going to have to move Barry up to the top of the class so that he becomes an instance variable. So now we have Barry and Kathy, and we need to implement urgent orders. So we'll create a method, and we're going to cheat here because we're just going to return a hard-coded value. But for the moment, let's make sure that the test fails for the reasons we expect it to. I'm going to run this again, and we're expecting the test to fail, like we did in the previous example. And now, effectively, we have this example fails, expecting a collection containing large cappuccino but was null. So let's hard-code this value once again. We'll just say that urgent orders is exactly the same thing as for pending orders. We're going to hard code the results. We run our tests again. And we have our passing scenario. Now these quick fix implementations like this are not meant to be permanent at all. They're obviously not future-proof, and we can't leave these around for production code. But they do help us think. They help us ask ourselves the question, what else do we need to test? What else do we need to demonstrate? How can we show that this test is insufficient? What other scenarios do we need to show that our application is not ready for production? That's what we'll be exploring in the next episode. In the meantime, take a look at the source code that we worked on in the GitHub repository that you'll see the link for at the bottom of this video. So that's all for this lesson. Until next time, this is John Smart from the Serenity Dojo signing out.